Hello, everyone. We're going to get started again. Dr. Ghoshal from Washington University, researcher focused on frontotemporal dementia and other dementias, is going to be speaking. So, Dr. Ghoshal, welcome up. Thank you.
Good afternoon, everybody. You can actually see me, yeah? Okay. Kind of often will disappear behind the podium. Maybe I will grab this as well. All right, so first of all, welcome to our fair city in St. Louis. Good to see everybody. I've heard so much about you guys and been working with Nathan and Allison and behind the scenes more with the standard of care work over the last 2 years now. So actually lovely to see people in 3D and not in just little Brady Bunch boxes on Zoom. Hopefully we'll keep this a little bit lively. I know it's kind of closing out the day and a lot that's been covered today. We're going to kind of pivot a little bit and talk about some aspects of the disease that are part of the name, but aren't as focused on, or certainly hasn't been a focus of discussion today. So maybe this will keep it new, fresh, and interesting for you. It's fantastic to be able to talk about understanding FTD and the ALS component of the disease. So let's get cracking. So some of this will seem like a little bit of a redux from the morning, but maybe that's a good thing, just a little bit, not a lot. So we'll be talking about the FD of IBM PFD, right? So on chromosome 9, I'll kind of careen through some of this, and the reason I'll do that is while we've been very focused on the muscle side of things, right, with inclusion body myopathy. We haven't talked much about Paget's today, but we're going to really focus on this bottom portion of the slide, not because it's the bottom worthy, but kind of rank ordered wise. Frontotemporal dementia can occur in about 25 to 30% of VCP patients. And the ALS or motor neuron disease component comprises maybe, let's say, another 10%. Now, this is all heeding things that Dr. Pfeffer mentioned earlier today about whether this is an under or over, and I think some of it has to do with where folks show up. So if you are coming to a muscle clinic, a neuromuscle clinic, how much and how rigorously the FTD component, so it's not just memory, we'll talk a little bit more about that, and behaviors are really being asked and asked about, may not be the focus for the day, right? It's a pretty busy, intense day with those multidisciplinary clinics, so it may not be kind of the thing that anyone's keying in on. So it may turn out that, as we learned in these natural history studies, that there's more of this going on in the background if we actually kind of turn our lens towards that. So we're focusing on the FTD component. As Brandon said, that's kind of my area of interest. But certainly in our neck of the woods, it's now considered an FTD ALS spectrum. So we're better and better appreciating and ascertaining those in our visits, the kind of full spectrum ranging from memory, behavior, muscle disorders, Parkinson's, ALS, the whole works. So we're trying to be as broad and encompassing as we can be during our visits. I pilfer quite a bit from Dr. Weil's paper from 2014 because it's great graphics and kind of helps lay the land. So again, while the focus and often the discussion, VCP bears around the muscle component, we'll ask you to pay attention to some players that he in particular focused on, ubiquitin and TDP-43. These will make a reappearance later in the conversation. But these are the common players, and I agree with Chris that it's not entirely clear why brain, muscle, bone are kind of the three tissue types that these two proteins kind of wreak havoc in. But again, we're focusing on that frontotemporal dimension, the upper right there. So let's get some kind of basic terms clear, right? Because we'll kind of dance around this if we don't take a moment and pause and say, what is this D of the FTD? So what's dementia? So we're diagnosed that often when people are having cognitive and behavioral symptoms. So cognitive usually equals memory, but in this case, we'll be talking more about the behavioral symptoms as well. And it's when it's not just a quirky person or a one-off, but when it's becoming a consistent issue, and it's interfering with someone's social activities or ability to work, and it represents a change from a previous higher level of functioning. So you can imagine like an accountant who's now having a difficult time balancing their checkbook versus someone who never could get it balanced in the first place, right? That's not a change for that person. A lot of text here, so suffice it to say that there's a pretty comprehensive evaluation we do as well. We are speaking not only with the patient/participant, but with the caregiver as well, someone who can give us that 365, 24/7 view of things. Some paper and pencil testing, bedside testing, exam, and at the end of that we kind of distill and we're looking for and listening for someone who's having difficulty learning new information, that memory piece. difficulty with kind of 3D assessment, where things are in the 3D world, tripping over things, among other things. But the last three that have underlined changes in language, reasoning, and personality that tend to be kind of cardinal features within the FTD space. Ergo why I highlighted that. So let's talk a little bit about the anatomy. So the frontal lobe, actually not highlighted here in any particular way in that GIF, but this is the part of our brain where we will often kind of commonly say someone's filter, or filter being present or absent. It's how we interact with the world, right? It's our personality engaging with the world around us. Along that, it has to do with understanding sequence of events, the consequences of events, knowing that step A has to happen before B, before C, all comes from this frontal lobe area. Emotional expression in the lower left as well. So this is an area of the brain that can become affected in frontotemporal dementia. Temporal lobe then is a little bit further back in the brain, sitting right above the ears, let's say, has to do with all aspects of language, the receiving of language, the comprehending, manipulating of that language, the production of language. And the center part of that lobe also has to do with short-term memory. So memory functions, language functions. Kind of breaking it down that way, because when these parts of the brain become impaired in disease, you have kind of the known consequence, kind of the expected consequences in terms of symptoms. So Dr. Weil talked about clinical presentation. So this is what the person looks like when they're coming through the door in our clinic, and what we're listening for, what we're looking at, trying to help categorize the kind of what's in the spectrum of frontotemporal dementia. A couple different ways to break this down. So as neuro geeks and nerds definitely have different ways of grouping things and classifying things. I'm going to offer one breakdown. So one is what had traditionally been called Pick's disease, or behavioral variant frontotemporal dementia. BVFTD, so behavioral variant, kind of gives you a clue as to what the main symptoms are. This is kind of the lion's share of the FTD that's out there at 60% or so. Big personality changes. This isn't Mars Venus stuff. This is, if I ask the question, this is fundamentally not the gal I married, not the guy I married. Real core changes to people's personality and take on life. And they're usually not insightful about it. They think I have a patient, unfortunately, right now in the hospital down the street who has no idea why throwing things at neighbors was inappropriate and landed him with the cops being called and so forth. He kind of can recount the event, but sees nothing wrong in his behavior whatsoever. Tend to be socially inappropriate. You'll hear about, sometimes in the press will come up with dietary changes, becoming very fixated on sweets and carbohydrates, high caloric things. And disinhibited behaviors, such that they're in church, or that Seinfeld episode with the Pez dispenser at the funeral type of thing, not making light of it, but that kind of really out of context, inappropriate behaviors. Language can be affected in these individuals as well, but notably, memory is usually spared. So when we often talk about dementia, there's an equating of that with Alzheimer's disease and a memory issue. So these folks have that particularly spared. They'll continue to do really, really well in our standardized testing, and yet are having profound difficulties in the real world and how they're interacting with people around them. Then there are language variants. So this is a frontal lobe-based set of features. Then if you go back a step in the temporal lobe that was talking about being language, there's language variants. Primary progressive aphasia, lots of words. Primary meaning the main thing of a progressive nature. Aphasia meaning language issues. Okay, so if your main feature is language problems, this is the category you fall in. There are two flavors here. One is a non-fluent primary progressive aphasia, and it's kind of telegraphic speech. You may have seen pictures and you're supposed to describe it and you say, ball boy kick. Yeah, the content is there, you're kind of describing the scene, but all the connecting words aren't there. Nowadays we hear about it more in text, when people are texting back and forth to each other, that it just doesn't kind of hang together. Communication is happening, but with not all the words. There may be kind of interesting spelling errors, so square being spelled S-W-A-R-E, kinda, but not quite right. And then the other kind of flip side of that is what we call semantic dementia. So classically in textbooks referred to as word salad. So just a lot of words, nothing being said at the end of the day. Kind of strung together words, not meaningfully so. And these people can have, what's on here, loss of word meaning. You ask them to pass you the spoon, and they kind of stare at you not knowing what a spoon is, might pass you the apple. right? So there's really just no connection between the picture of the word and the object itself. And these folks can fit a little bit more of an Alzheimer's type of picture as they kind of progress. Just kind of nature of the fact that their temporal lobe, the middle part of which has to do with memory. So it's kind of adjacent areas that become involved over time. This is the circled entity that frontal lobe kind of disinhibited behaviors is what we are hearing about mostly in the VCP folks population. And that's kind of the lion's share anyway, 60% or so. The way we kind of go about sorting out, other than history taking, which is, as all things in neurology, is where the money is at. So we spent a lot of time talking about historical features. Are these things happening? There's a set of criteria that were published in 2011. It's kind of a schematic of that. So in the leftmost panel, you see kind of those features I was highlighting in the previous slides about kind of socially inappropriate behavior, loss of empathy, lack of apathy, presence of apathy, kind of have OCD types of behaviors, be very, very hung up about doing things as just a certain way every day. And these are things that occur early on in these like the first year, 2 or 3. To add to that then is the middle panel where we'll do some neurocognitive testing. That is now the better term than neuropsychiatric testing. And looking for, in this case, specifically kind of preservation of memory, so not the Alzheimer's type of business of episodic memory issues, but rather executive function difficulties. So the ordering of events. Some of you may have done things like Trails A or Trails B, where you have to connect the dots or letter dot sequences, number letter sequences, and keeping that straight, right? Those two sets of information go 1A, 2B, 3C in a timed fashion, has to do with your frontal lobe and executive function. And then ideally, we also have some imaging evidence as well, that's that last panel on the right, that supports this, where we'll see involvement of the frontal and temporal lobes and say, yes, this all kind of fits together. We have the symptoms, we have the bedside testing results, and the imaging kind of all hanging together. Yes?
When you say with imaging, does the frontal lobe or temporal lobe, do they shrink? Is that it?
Fantastic intro to, next slide. Read my mind, exactly. Yeah, you got it. Let's see if this is going to work for us here. Yeah, and if I can drive with either hand. Okay, here we go. So kind of very stylized pictures. Is that laser pointer not going to turn up? Okay, we will point. Yeah, but I think it's not going to pick up on the camera, it seems like. So side view of the brain, going from the back to the front. You could look at how brain ever grew out to this kind of outermost part. These crevices start getting a little bit wider, wider, wider as we come to the frontal lobe up front here. And the brain, it's a little bit harder to see in these pictures, has shrunk back from this white line. This brain really grew all the way out to there. The middle panel is an elevator view of the brain. So we're coming up like so, for camera purposes, up like so. And again, the brain would have grown out to this outermost portion. These are the temporal lobes, so it's shrunk back. And this is a higher view, still in that elevator view of the brain. Again, if you look at crevices and so forth further back, looks okay. And you see that shrink back up top. Admittedly, in a dramatic example, and not necessarily for VCP, but just for demonstrating FTD. We can do PET scans, FDG PET scans. So this is looking at the brain and how it uses glucose. Brain ends up being pretty greedy about 2 things, oxygen coming at it regular and sugar coming at it regular. So you can think of this as a heat map or a weather map, if you will. So often in the scenario for cancer, you're looking for hot spots. In dementia, we're looking for cold fronts. So here, in the back half, again, these are more elevator views of the brain. Pretty much draw a line straight across, right? So hot and warm fronts in the back portions of the brain, and then the frontal and temporal lobes being pretty darn blue and cold. So that information, so thank you for asking the question about the imaging, helps us make the diagnosis. But like I said, this is what we do when we see a person coming through the door in clinic. But there have been far more, I think both Dr. Seffer and Weil talked about this, revolutionary rethinking of these disorders and we pivot back to VCP, so the molecular side of things. A lot of information here as well, but it turns out that in FTD space, we can pretty much pinpoint the gene or proteins involved, kind of subserving those symptoms. So the symptoms can overlap, can be a mishmash and overlap in a spectrum, but we, at the end of the day, can get back down to the genes and proteins involved. And you might recognize this green stripe down the center, TDP, so that TDP43 protein that we've all been talking about all day. And then further on down, VCP. I mentioned 2003 because the other kind of leading contender in dementia is Alzheimer's disease, talked about since 1905. And so in fact, the VCP and FTD connection has been a much newer thing. 2003 still seems like a long time ago for some people, but in the space of all kind of dementia research, a fairly new player. Back to Dr. Weil's 2014 paper, and I won't belabor this because it was covered earlier today, but the fact that VCP has so many different functions, at so many critical points in cell function, okay? And things like amylox now kind of fit on the left part of the scale here, which is interesting because if we associate any mutations in functions with VCP, end up being on the right side of the screen, as Dr. Weil talked about as well. So it's interesting to think about what if we could just fine-tune VCP that isn't quite working right. Can you get it, knock it back into place, make it function the way it's supposed to? And notice I'm just going to leave it at modulating as you did. Whether that is a increase or dialing up or dialing down, we'll kind of leave be. But it also makes sense. It would have, it's kind of a tantalizing target that way, right? Because it could potentially improve a lot of different functions or optimize a lot of different functions. And here, since I'm also talking a little bit about ALS, is another similar view of a cell. A lot of different components here, but you'll see kind of common themes coming up again from the previous slides. So it turns out VCP interacts with pretty much every kind of biomolecule. So we'll talk about ubiquitin and proteins on one hand, so protein folding and degradation has to do with RNA. Armel was talking about transcripts, that's RNA, trafficking of all this good stuff back and forth. And these are all impacted in ALS. And you'll see a set of common players for ALS with C9, TDP43, FUS, and SOD1. Yes, I know VCP is notably absent there, but imagine it's there. And it turns out that these are the functions that, again, amylox could potentially address, and why there's probably been, so FDA, not FDA approval yet. I think that's coming back in September. That's going to be back on track. But it's been approved in Canada, right, Dr. Pfeffer, I think in June or so. But why it makes kind of is tantalizing as an agent and how it could be far-reaching through a couple of these different pathways. I'll highlight one more thing on this slide, the accumulated neurofilament. Heard a little bit about neurofilament earlier. We'll talk a little bit more about that. So in terms of proteins that have gone, good proteins that have gone bad in these diseases. So a lot of why you're here is we're interested in research, and we are too, in the FTD ALS space. So what all could you do to get involved with research? You already do a lot, understand that. And there's opportunities to do more and maybe in different ways. And what I was trying to say earlier during Dr. Muzaffar's, during that Q&A, to be very complementary to things that are efforts that are already ongoing. Excuse me, tapping into networks that are already in place. So back in 2014, we started an initiative. This is NINDS, so through the NIH, funded along with NIA, I should say. So two different institutes at the NIH. The two studies were Artful and Lefties. I do not come up with the names, I just report them. Artful was for folks who had sporadic garden variety FTD, and Lefties had to do with hereditary forms of FTD. Admittedly, Lefties was focused on, quote unquote, the big three, folks who had mutations in the tau gene, progranulin, and C9, but it was really ever intended, and that's where the numbers were, to be all-encompassing for hereditary FTD. So that funding cycle went through 2019, then we went back in for renewal and was funded again in 2019. You'll notice this is no longer a 5-year grant, it's a 6-year grant accounting for COVID. We've gotten a year extension accounting for that, and we've rebranded as All FTD because in fact now all FTD can be recruited for this study, so sporadic and hereditary forms. This is our network in North America, so 20 plus sites. We did grow from the original 8 sites, for which WashU was one of the kind of founding sites, to 20 plus entity now. This is what I was kind of alluding to with the prior session. This is already in place, and there's a great opportunity to kind of tap into existing networks while additional funding is being applied for in your space. Let me back up for just a second and explain a little bit more about what we do. I kind of thinned out my slides yesterday thinking this was going to run long. So for all FTD, much like some of the other studies you heard about today, our annual visits on site originally kind of as intended, detailed interview, exam, physical exam, blood work, MRI. If a site has an interest in PET studies and so forth, can do that. Blood draw and spinal fluid collection. Spinal fluid is not a requirement. It is highly encouraged because this is how we're learning about that's the space closest to the brain that we can learn quite a bit about proteins that go up, down, and around. So that's kind of the annual ask. Of course, during COVID, we had to pivot pretty quickly. We also then developed remote strategies and what we could do. We've since, so that worked okay. But it is fundamentally a biomarker study. We rely pretty heavily on the interview part could be done, maybe even aspects of the exam could be done in video. As you see, this can be done pretty credibly. But the MRI, the blood work, and the spinal fluid was becoming, those are not remotable, let's put it that way. So as part of this was kind of an ancillary study then, so we have all these sites up and running, as we had the neurofilament surveillance project. So neurofilament is that protein, good protein gone bad that's accumulating in ALS, among other disorders. So what could we learn about neurofilament and why should we care about it? So neurofilament light chain, NFL, not football. So broadly speaking, it's a protein that you saw in that cell figure that I showed you. It kind of clumps up in the axons, and kind of if a neuron is damaged, you might see an increase in neurofilament light chain as a signal. So at least a broad indicator that there's been neuron injury. And we had data already leading into this project that maybe before these slow-moving diseases, yes, there are rapid portions of it, and the neuromuscle part tends to move faster as well. But it's a disease that if we were going to do the natural history stuff, and you're looking at 3 and 5 and 10 years of disease, of symptom development, what is that window that would let us know that we're about to embark on that journey? And is that maybe the window, that pre-symptomatic or early symptomatic phase that we could intervene when we have therapeutics? So what about getting some good measurements about something like NFL before the symptoms start? So part of this was, admittedly, a natural history study, but the FDA was very interested. So even during COVID, they're like, you know, if you can't get the in-person visit study, if you can at least get this thing going, that'd be huge. Because they're willing, as a surrogate biomarker, as Dr. Mazzafer was talking about, so something that indicates what's actually going on. There's a threshold. We could argue about that above 15 or below 15 was a tell about disease to come. And then you could talk about flattening that curve. So it was going to have a certain trajectory, and we can ask if a drug can level that off. We need some information about that. So the idea is getting information about the disease course, what happens with neurofilament. Can we find that window before the symptoms start? And would that be a time to be able to intervene? So how did this all play out? So this was studies coming to you. It's not quite remote in the way we've just been talking about. It was typically paired, certainly with an all-FTD study site and a study visit typically. But a research nurse would come out to you, your location of choice, once every 3 months for some blood draw over a course of 3 years. And at the very least, the ask was that we would be measuring the neurofilament light chain, but there was a discovery component as well to see what else might be changing. And the interest for all this is a lot of what's been talked about here. For any kind of a drug trial that Armel was talking about, no one's interested in bending the clinical curve in a 3, 5, 10-year time frame. And people are interested about what can we change in 12 or 18 months. And it's tenable that neurofilament might be that measure, and the FDA seems fairly bought into the data we've been able to present to them so far. Another way of looking at it, that was a cute little graphic with a neuron. So in terms of the idea of time linking it with the in-person visits when we've got those back up and running, and continue to have these 3-month samplings for a 3-year period of time. So you can imagine, even when we did a blood draw in person, That was once every 12 months. That's all we had. That was the data we had. But now you had the opportunity of being able to sample and track something multiple times a year. Kind of get that granularity that we didn't have before. Yes, yeah.
Are those at-risk patients or are those patients that already have dementia?
They could be both. So they just need, in that particular part of the study, the question was if those were at-risk people or folks with disease. Both. So and the criteria for that is you had to come from a family with either progranulin, tau, or C9. You did not have to know your own status. That's kind of done behind the scenes. So you could just participate and not know, like, hey, my brother got called and I didn't, so does that mean something? So that part was kind of taken out of the equation. Also part of all FTD was borne out partnerships with the Association for Frontotemporal Dementia, and what came out of all that was an FTD registry. The FTD registry is also for all comers. I know you have your own registry, but this is, again, for those of you who may be encountering the FTD component of the disease. Certainly encourage you to get enrolled in this. It's one-stop shopping that way as well. The idea is it's a platform for A, getting registered, B, a point of dissemination for education purposes, support, and then even study items. So the idea is this will be a launching pad where surveys and things like that could be launched from. This is, as of earlier this week, now fully staffed. Been understaffed for quite some time. And then y'all probably know about clinicaltrials.gov. Just took a look to see what was up there for VCP. Gives you a lot of cancer stuff. So you look at for IBM, PFD, kind of ongoing studies, but these are the ones you guys already know about or are participating in. A couple other useful websites. So I mentioned the Association for Frontotemporal Degeneration. They are a smaller group than the Alzheimer's Association. They have it a little bit further down, but much more focused in on the challenges supporting the FTD population and caregivers. FTD registry that I just introduced on the prior slide. And you might be surprised I have the Alzheimer's Association, since I just spent time explaining how we're different than Alzheimer's disease. But at least in the St. Louis area and kind of nationwide, they're a larger, older organization. And in the St. Louis area, they actually have support for caregivers, younger onset dementia. So they really don't differentiate at that point when it comes to support purposes between whether you have Alzheimer's or not and what your challenges are exactly. And then if you're interested in further evaluation, this is our clinic here at Washington University. Whether if you want to have a clinical referral, you wonder if this might be something that you're dealing with, you, your loved one, what have you, we certainly can do the clinical evaluation. I can go into more details if that's of interest. And then we are obviously a very one-to-one link with the research. Again, each thing can happen separately. You don't have to come through the clinic to get into research and vice versa. I'll leave you with that. Have additional slides if depending on kind of questions as they come up, but happy to take questions.
Video.